So we have covered several sections so far. So we have discussed about the ESP32 pin configurations. Then we have discussed about uh, the different communication protocols that can be used for ESP32 to another ESP32 communication, or ESP32 to another device communication. So you can, we discussed about UART, SPI, I2C communication protocols. Apart from that, we also discussed about how we can set up an IDE, which is an integrated development environment that can be used to develop the code that we are going to embed in the embedded system. So we discussed about installing UPyCraft IDE. So we also, I think, we discussed about other IDEs that are available for use. So other IDEs that can function with programming languages such as MicroPython, C++ were discussed. They can also be used for the activities that we are doing in this module. So then we actually went through how we can upload a certain firmware, some kind of a language, MicroPython firmware into the ESP32. We also learned about how to run sample codes in the ESP32. After that, we discussed about ultrasonic sensor and how ultrasonic sensor works, and its basic concept behind the distance measurement that we can do using ultrasonic sensor. So we can use the reflection of a certain ultrasonic wave once it hits a certain obstacle, and we can use that time of arrival concept to measure the time that it takes for a certain signal to reach and hit a certain obstacle and return back to the original device or source. So using the time of arrival concept, we were able to use the ultrasonic sensor to do distance measurement. So after that, we discussed about the ESP-NOW protocol. ESP-NOW protocol is a short-range communication protocol that can be used to communicate between two ESP devices using a certain technology that is enabled with this ESP-NOW protocol. So it's just like Wi-Fi, Bluetooth, and other short-range communications. However, ESP-NOW protocol is basically defined for ESP32 microcontrollers, and it is available as a library in the Arduino IDE. So you need to use Arduino IDE and the libraries defined in that environment to enable this protocol and the communication. So up to that point, I think we have discussed about the IoT implementation work. So I think for you all, I think I have given some assignments to do, and I have uploaded the submission links in the LMS. And up to the point where I have asked you to do assignment on ESP-NOW protocol, I have uploaded the assignments. So up to that point, that is up to that point we have discussed. So do you have any questions up to that point?
Excuse me, miss. This is regarding the ESP-NOW assignment.
Yeah.
When we used to communicate the two ESP32 modules, we want to update the firmware, no?
Sorry, update the
Upload the firmware to the ESP32.
Yeah,
when
we
we
need
are
to
doing?
upload the MicroPython language or some kind of a, language-based operating system, right? So that software we need to upload into the ESP32. So already, if you have uploaded one time, it will be there. So you don't have to reinstall it multiple times. Is that what you're asking? Whether you need to
Yes,
reinstall
miss.
again?
Yeah, when if we want to use the Arduino IDE again, can we use it again for that purpose?
I believe you can use without any interruption from the other IDE or the other firmware installed. You can use both the environments without any disturbance or any kind of crash. So you can still work with Arduino IDE without um, installing it from from the initial stage, according to my understanding and what I have experienced. So normally Arduino IDE works fine even if I install the MicroPython firmware and then I run the Arduino IDE. It still works. It still works. So I think I will try to see whether it is the case. We can just connect the like our microcontroller and we can check. So um, so most of the time it is possible. Otherwise, actually, we need to install the IDE again. Um, one thing with the, I mean, one thing with um, certain IDE that we are installing to uh, IDE that we install to do the coding is sometimes affecting the ability for us to have the code stored in the board for a continue I mean for a continue for a long time. So what I mean is that sometimes if you use UPyCraft IDE, sometimes we will see that we might not be able to see the code available in the board for a long time. So I believe so. So I believe you. So this is after some time that I'm doing this. So if I get an error, then I need to reinstall the firmware in the board. So if that is the case, I need to install using the usual manner, and I need to install the firmware in the board. Um, so it seems that uh, I cannot run this at the moment. So that means I need to upload the necessary files and run the code. So I will try to see whether. So I believe you need to install the firmware again, but it could be that I'm using this after some time that it is not getting. Uh, I mean, it is not shown in the board. Maybe I have resetted have reset the board contents, that the firmware also must have uh, got, I mean, removed due to multiple resetting instances. However, like in this manner, you can install the firmware again, and then you have to run the codes if it is missing. Otherwise, I think with other IDEs, so I don't know whether I don't think we can use two IDs at the same time. We need to first work with this first and then work with the other one. So let So for the Arduino
Madam,
IDE, it is
yeah,
working.
did you try the that firmware previously? You upload that firmware, no?
So this is Arduino IDE one.
Yeah.
So this is not the UPI Craft one.
Ah,
So this has been already installed in my computer, and it it runs the code in the board without any I mean new uh, flashing of firmware. I don't need to do any new initialization. So I mean, so the Arduino IDE, I think you can use without re installing the firmware in the microcontroller board. Arduino IDE there's no problem, I think. Uh, so the problem was, I think, with the other one. So is that what you wanted to clarify?
yeah, Miss. Can you upload that firmware and try?
So yes, I need to go through the that process again. I will try to close this. So in the as it seems there is the ports already uh, ports already identified by the computer. So
Miss, what is that burn address mean?
um, you mean in the previous um, I'm not very 100% sure. Is there an address?
Yeah, yes. So that's why I asked.
Address means uh,
I saw that some 0x00 and you put that
yeah. So you need to set it to, I think, to that value. So um, I think I mean my idea was that you can enable I mean large amount of data upload into the microcontroller when you set that setting. Otherwise, I think 0x0, it's like a hexadecimal address, right? A hexadecimal number. So something related to the amount of data transfer. I was actually I also need to refer that exactly, but
in here.
sure
You
about
just
that.
only that change that value and retry it again. No.
Yes.
Ah,
So in here I have to select yes. So
okay,
I
miss.
think due to some reason this is not getting installed in this moment. You need to try it multiple times and
Yeah.
get it done. After that, there should not be any error in here. So you should be able to get the board connected once you click the connect option, the board should connect to the this IDE. So that is the initial part that needs to happen. So until that point, you need to try to do the burn firmware part. So maybe you can try on your own when you can. So yeah, now at the moment, due to some reason, this is not getting correctly done. So sometimes it happens maybe because the connection is not as secure, or connection is not that stable with the controller and the IDE. So maybe after several tries it can be done. Also, maybe you need to reset the code that is already available in the microcontroller and then start again. So maybe resetting can be done, and then you can push the button, the push the reset button in the microcontroller, and then you can maybe try it again. So uh, currently my I think burn firmware part needs to be completed again. That part will take some time. So that is the kind of the delay that is there. So I need to try it out sometimes. If it gets successfully done, then I think I will be able to connect the board to the IDE without any problem. So as of now, this is what it is. So I will just let it run like this for the moment. No, it is maybe I need to restart again this process. Anyway, you can search about the burn address thing. Actually, it actually points to some an address that is there in the microcontroller uh, board, and to address to a certain component in the microcontroller board. So it so that address points to a certain component that helps in the firmware um, installation in the microcontroller board. So maybe you can search about that in your own space. So a specific component is used to do the burn firmware uh, process, and that address in which the data should be sent is, I think, defined under this burn firmware burn address part. So you're basically defining the address to which you need to send the commands for this installation and for this initial booting of the microcontroller. So I just suggest that you do some literature survey on that. So that is, I think, regarding the IDE and their compatibility with the uh, with the with the board. So you can try to work with the most comfortable IDE that you are comfortable with. Sometimes UPyCraft might not be the optimal one. So as I think there are other IDEs that you can work with. So you can also try them out. So I just selected this one mainly because I think that this is a very basic one. So I think that this takes lesser time for a code to compile. However, you can try other IDEs that we have discussed about, and there are other IDEs that you can find on your own. And those IDEs, such as Tony IDE, even VS Code plus other extensions and PyCharm, those IDEs also can be used for embedded system coding. I think those IDs are much easier to function and work with, and this is actually sometimes a challenge. But I think it also works at the end. So maybe you need to test out different things. I believe that you can actually work with two IDs at the same time, I mean, stored in your computer. Arduino IDE also can be there in the computer while you're using your PyCraft, but both IDs cannot be used for, I mean, coding at the same time, but you can use one ID at one time and then use the other ID at another time. So I believe I think we discussed about that question now. So I think we will have to move on towards the next section. So for the regular students, I have done I mean sessions about the protocols. So I think in the last class we discussed about protocols in different layers that used in IoT systems. So in today's class, we'll be focusing on those protocols. However, main focus will be there for the MQTT protocol, which is one of the protocols that are used for IoT-based scenarios. So specifically for IoT scenarios, MQTT protocol and other protocols such as COAP protocol are used. So we will discuss about those protocols and how they can be implemented in the ESP microcontrollers, uh, and how we can establish communication between two devices using the MQTT microcontroller. So if you have any further questions, you can interrupt me in the middle. So until I get the things ready, I would like to get attendance. So if possible, please mark your attendance.
Excuse me,
Yes, sir. Yes.
Miss, very sorry that I could not save the link. Could
Sorry.
you please?
Sorry.
Extremely sorry for I could not save the link to mark the attendance. Could you
So
please share it?
you can't see the screen. It is already
Uh,
there
I
in the screen.
I
Uh,
the link.
so the link you need to, I mean, is in the attendance.sltc.ac.lk, right? So other times, please ask from your friends. Maybe if you cannot find it. So did you mark your attendance? Yeah, I think both of your IDs are there. So I think I will close this. So I think we will discuss about the MQTT protocol today, and we will discuss about their implementation. So okay, so the MQTT protocol that we were discussing about was like this. So when we consider a small example, um, where we have some measurements that we take about the environment, we can take those measurements and we can name those measurements as temperature, vibration, humidity, likewise. So the measurement collector will be able to publish the data under that certain temperature topic or maybe vibration topic in the MQTT broker. So the MQTT broker will collect data under each topic. So the topic will contain all the data that has been sent by the publisher. So once the broker has the data, broker will update the data to the subscribers who have subscribed to that specific topic. So the subscriber who has subscribed to vibration data, they will get the vibration data into their devices. And if they have temperature data, then temperature will also be given to that device who's asking the temperature data. So likewise, for different devices, the specific data that they have requested will be distributed by the MQTT broker. So MQTT broker is such kind of a like organizer of the data, and a person who knows all the information about the connected devices. So there are different types of brokers that we can see that is in use. One thing is the managed brokers, and the other type is the self-hosted brokers. So managed brokers means that third-party brokers that are available, which means that there are third-party companies who make these MQTT servers available for its customers. So we have to pay to this company and get the MQTT broker for our use. So these are the companies that are basically doing this: AWS, Azure, Mosquito, Hive, MQ. So those companies are providing the managed brokers or providing MQTT brokers to customers. So that is one option. Another option is self-hosted brokers. Self-hosted brokers means like brokers who are hosting, brokers which can be hosted in our own devices. Mosquito and Hive MQ also are companies. They are also providing some open source services to the people. So people who can access the Mosquito servers and Hive MQ servers can install the MQTT MQTT protocol based functioning server in their own devices. They can either use the Mosquito servers or the servers that are available in this mosquito, infrastructure, or else they can also install the software in their own devices, in their own laptops, or in their own devices which they use to collect the information from the sensors. So this broker can also be even another embedded system. It can be a Raspberry Pi and such kind of a embedded system as well. So this server can be installed in other devices, and it can be installed as a certain software. And then using that software, we can enable the MQTT protocol. So MQTT protocol, therefore, can be used by either paying the third-party company, or else we can use the open source softwares to build the MQTT protocol in our own devices. So what we are going to do in our projects are basically use the open source Mosquito servers that are available for free, and install the Mosquito server in our own devices and implement the MQTT protocol. That is what we are going to do. So MQTT, so if we want to implement the MQTT protocol, we need to have a solid understanding or good understanding about the protocol functions. So protocol actually has basically 3 devices that are doing the communication. One is the client or the publishing device who's publishing the data, and the MQTT broker who's in the intermediate location between the publisher and the subscriber. Third one is a subscriber. So the data that the MQTT broker receives, the broker keeps that as a list under certain topics. So a list of topics MQTT broker has. So MQTT broker maintains a list of topics. And then data is stored under each topic by the broker. So whatever the most recent data and total amount of data that it receives, it will save under the certain topic. And based on the frequency that is defined by the subscriber or defined by the user, the MQTT broker will provide the data as frequently as requested by the customer. And the client will also have a certain frequency of uploading the data to the broker, right? So there will be a certain rate of uploading, and there will be another maybe different rate of offloading the data back to the subscriber. So that process will happen during this communication. So when we are trying to implement the MQTT broker-based MQTT communication, we need to set up MQTT broker first, and we need to set up all the configurations in the broker such that we can connect our devices into the MQTT broker. After that, we need to set up the MQTT client device. The client device can be set up by coding on the embedded system. We need to build the code inside the embedded system in such a way that we can transfer some data such as temperature into the broker. So we need to have some temperature sensors connected to the ESP32 for this to happen. So we can obtain data from the sensors, and we can upload that data into the MQTT broker. And once we have all the data at the MQTT broker, we will then send the data to the certain subscriber, and we will send that using maybe according to a certain frequency, and we will receive the responses back from the subscriber to the MQTT broker if it is also defined in the algorithm. So first we do the coding on top of this ESP32, and then we do the coding on the subscriber device. So publisher subscriber devices must be configured, and the coding inside them need to be configured such a way that they act as publisher and subscriber. And also, both of the devices can function as either the publisher or subscriber at the same instance. So we need to develop the code inside these microcontrollers such a way that they can act as both the publisher and the subscriber. So that is the process of implementing the MQTT protocol in general. So this is one of the simplest, I think, steps to follow in this situation. So you will be setting up the MQTT broker first, then you will be setting up the publisher, then you will be setting up the subscriber. So there's some sample codes that we can follow to establish the algorithm in the ESP microcontroller. So before establishing the microcontroller, we actually need to install the MQTT server in our devices. So in order to install the MQTT server, you can download the Mosquito software in your devices, right? So we need to install the Mosquito, right? MQTT software in our devices. For that, we can type Mosquito MQTT. Then we can go to Eclipse Mosquito page, and we can go to downloads. So downloads, and we can download the version that is available for Windows, for example. We can download the 64-bit version or 32-bit version. And then after downloading, you will be able to see that it is installed software in here. So I think I have maybe I have deleted that. So I will have to install that in here. So you need to run this software, and you need to get it functioning in the computer. So once so I had Mosquito already installed in my system. So because of that, sometimes I cannot install it again in the same folder. It is already there, I think. So I will just cancel this one. So since I'm having Mosquito already installed, I don't need to install it again. So initially you will have to install it, and then it will be there. So once you have installed and it's already there in the directory in your computer, then you need to check whether Mosquito service is running or not. Now, in order to do that, we need to we need to open up the CMD, the command prompt terminal. However, in here, actually, I don't need the normal version. I need to run the command prompt in the administrator level. So command prompt in the administrator level, so run as administrator. So I will be asked to give permission. Then I will have to check whether my MQTT broker is running. So I will give some command and I will check. So I will type command net start Mosquito, and then the requester service has already been started. So it says that Mosquito service is already running in the system. We can also verify that using task manager. So the task manager will show me whether this service is running or not. So I can go to the task manager and go to the services, and then I can go to the Mosquito server. So in here, Mosquito broker, it's shown that it is running. So because of this, I know that mosquito server is running. So if that is the case, then no problem. Then I need to then use a user interface, which is providing me the ability to observe the data that is reached, that I can receive through the MQTT service. So I need to install a user interface such as MQTT Explorer. So MQTT Explorer you need to install. Yes.
Madam, how can you open the administrator command prompt?
So the command prompt, you can type CMD, and then you just will get the either you can right click to that and you can click run as administrator. So, or else there's another option in here to run
Okay.
as administrator. Are
Then,
these
what
options
should
available to
we-
you?
Yeah, I
Yes.
already installed with you, and
So
and I opened the command prompt. What shall I type in
Yeah.
here?
Okay, in there you need to type net start mosquito. So net start mosquito. I will put that in the chat box. So net start mosquito, and then you can see the output, and you can check whether your output is showing that the mosquito is running or not.
Okay, Miss, it appears running.
Great. So after that, you need to, keep it like that, and then you can then use this software, MQTT Explorer, and then you need to download it for your system. Right, so the download link must be this one. So you can go to Windows and you can go to installer, then you will be able to download it. Hopefully this is the correct link. So I already have downloaded this. I don't know whether you can run this one, but I will try to run that. So it will say that it is installing, and then will give me some next steps to follow. So after, it's done very fast. So this is the interface of that MQTT Explorer. So did you get up to this point?
Yes, madam.
Okay, so great. So first, so you have the option to connect your local device as one of the MQTT servers. So you can convert your local device, your local laptop, as a to a MQTT server. You can convert your laptop to MQTT server. So how can you do that? That is the question that we are trying to address here. So you know that your device has a certain IP address. So you need to give that certain IP address to this interface, and you need to configure that IP address as the address to where the server, to where the server is at. So you need to find your own IP address, and you can do that by using the whatever the command prompt that you have. You can type the IP config, and you can basically find the IP address of your device. right? ipconfig, you can type, and then you will get the IP configuration data regarding your device. So you will obtain IPv4 address that you have currently, the IPv4 address that you have been currently assigned with. So this is the latest IP address that is assigned to your laptop. So what I mean by that is that once the Wi-Fi changes, this IP address also changes. Right? So as the Wi-Fi changes or the connectivity changes, then you need to define a different IP address as the IP address of the device. So once I give the IP address as the host or the hosting server, so the MQTT is host at this server, and then you need to define the port through which the MQTT data will come through to the device. So the 1883 is the default port used for MQTT communication. And then we will try to connect this one, but I don't know whether it will connect. Yeah, there's an error coming in here, right? So this is an error that comes due to a reason such as the data not being forwarded to the proper location, such that the device or the computer obtains the data through the necessary port, right? So the necessary port and the IP address must be defined properly for the communication to be done and the data to be forwarded to the necessary location, such that the data can be viewed through this server, and we can observe the data through this user interface MQTT Explorer. So we have to have the IP address and the port numbers correctly defined. If we don't have it, then this disconnected from server will occur. So what to do about this one? So this is an error. So we have to resolve this error, and we have to actually forward the data that is coming to the IP address, this IP address, to another address that is specific to the your laptop or to your personal computer, which is 127.0.0.1. So this is a unique address to each of the devices, that we have. So this address is known as a loopback address, and that this address corresponds to all the network connectivity related to the device. So if I try to connect this one, I will be able to connect my device into the server. So I can access the server interface once I give the IP address as 127.0.0.1. So I will be able to access through this IP address, right? And some default data will be there. And you will be able to see the topics that are defined under the broker. And there are different types of topics, and under the topics, the data are defined. So these are all contributing to the topic in the broker. So, however, in this kind of scenario, if anybody else also define the IP address as 127.0.0.1, then that person also can include the topic in here and include their data in the server. So in order for me to just have a server for my own IP address and to make it secure, I can actually forward the data that I received to my own address to this network address and to this network port. So I can remove the error that I get once I give the IP address. I get an error saying that I will not be able to connect to the server. In that case, I need to give an additional command in the command prompt. So since I get an error in here, I can give additional command in command prompt, which I can find the additional command in the LMS. In the LMS, I have given this guide guidance and the code that you need to type in the server. So it is known as this net port forwarding from one IP address to the local network IP address to do the mosquito MQTT communication. So maybe, okay. It seems that that website is not available anymore. However, like you can forward the data that is coming to a certain IP address to the loopback address using that command. Once you give that command, you will be able to forward the data that is coming to that certain IP address to the network IP address of that device and make that data appear in the interface. So I would like you to I would like you to visit the video that I have done previously regarding this network port forwarding situation and regarding like resolving this issue. So I would like you to follow that tutorial where I give you the command that you need to type in here. Sorry, type in the command prompt that can do the network port forwarding procedure. So, so that is regarding connecting our device as a IP MQTT server, right? So establishing MQTT server is what we need to do first. Right after that, you need to connect your ESP microcontrollers and you need to develop the algorithm in the ESP microcontrollers, right? So sample, projects that does that are uploaded in the LMS. So you can visit this page and then you can follow the different steps that are mentioned in here. So first, setting up the MQTT broker we have done. Apart from that, next we need to set up the ESP1 and ESP2 microcontrollers, and the code that we need to implement in the ESP1 controller for this specific scenario is given in this web page. So this scenario, they are publishing a certain data to the hello topic, and that ESP microcontroller number 2 is subscribing to the hello topic. So the data that is sent to the microcontroller, the MQTT broker will be under the topic hello, and the data will be stored inside the broker. Subscriber will obtain that data. So likewise, publisher, subscriber, they need to publish and subscribe to certain data. So the procedure of implementing that MQTT protocol is given in this website. So you need to have the MQTT broker, ESP microcontrollers, in order for this to for you to implement this. So you can try to complete all the hardware necessary to do this work. So if you don't have any sensor measurements, maybe you can try to send some string data to the receiving broker. So you can decide what type of data you are sending initially to test the connection between the MQTT broker and the devices. So after that, you can implement your own algorithms in the embedded system. So that is regarding the implementation of the ESP microcontrollers and implementation of MQTT in the ESP microcontrollers with the help of MQTT broker that you install in your own device. So using this, you can do the communication between the two devices, the publishing device and the subscribing device. So do you have any questions up to that?
Madam, actually, what is the problem for the code when you connect the IP address in MQTT protocol
So now,
previously?
yeah, so the data that is coming to the IP address, my local device has a certain IP address. So that IP address can be something like a 192.168 52.8. some kind of IP address. So I have a certain IP address. So the data that is coming to my IP address is not getting forwarded through the specific port, which I define as the port that forward the data that is related to MQTT. So once the data is coming to that IP address, that data is not getting correctly forwarded to the necessary port, and after that to the necessary application, such that the application receives the data. All right. So the IP address, although I receive some data to the IP address, that data is not getting forwarded to the necessary port and thereby to the necessary application. Is it clear to you?
Okay, miss.
So once that happens, I need to transmit the data that I obtain at the IP address to the next IP address that I rely on, which is the loopback address 127.0.1. I mean, the loopback address, which is also another IP address that is responsible for network connectivity, network functions. So that IP address will be defined for the data. The data will be transferred to that IP address, and then the data will be able to access the MQTT server, and the data will be sent to the MQTT server. So the data, once it receives, will be shown in the MQTT server interface. So that is regarding like port forwarding that we need to do if we can see that the port is not able to obtain the data properly due to the IP addresses that are defined. So then we need to forward the data that is arriving at a certain IP address to another IP address, and then we need to like forward the data. I mean, we need to define the address for the data transmission, such that the data will be received at the necessary port, and thereby the necessary application. So that is basically, I mean, what we are doing there. We are defining a new IP address for the data to be transmitted to. So the command that I need to input there to do the port forwarding case, you can refer in my previous video regarding this section. So I hope you will be able to find it. So so regarding MQTT protocol, I think I discussed about the case about implementing the code in each of the ESP microcontrollers, and then we can establish the communication. So this has to be done in a practical manner. So I believe that you can implement it, and then you can let me know if you face any problems. So next part is regarding the MQTT protocols behavior under different quality of service levels. So in the MQTT protocol, 3 QoS levels or quality of service levels are defined. So these quality of service levels are defined to ensure the reliability in the communication. So quality of levels and I mean, they correspond to a certain level of reliability. So quality of service level 0 has the least reliability in the communication, basically. And in there, actually, we transmit the data to the broker. And I mean, we publish data such as temperature to the broker, and the broker will receive the data, and the data will be forwarded to the necessary destinations by the broker. However, the broker does not provide any acknowledgement back to the client. The client does not know whether the data that I sent to the broker was received or not. The client do not have any idea or clue about the data, whether it was received or not. So this kind of a quality of service level is suitable for applications where we don't care about data losses much. right? Data losses do not impact the end result much. So in such case, we can actually use the quality of service 0. However, if quality of service must be improved than that, then we can use quality of service 1, which correspond to the case where we send the data to the broker and we receive some acknowledgement back from the server, right? So in this quality of service level 1, we can send the same data multiple times to the broker, and the broker will compute all the different duplicates of the same data at the broker. So the broker will compute the same or do the same processing multiple times once it receives duplicates data, right? So when we consider about QoS level number 2, the QoS number 2 is defined such a way that only the data will be processed only one time at the broker. So which means that the data that it receives will be processed at one time, and if it receives duplicate data, the broker will not process that duplicate data. The broker will have some memory about previously processed data, and it will not process the same data twice. So those are the basic QoS levels that are defined for the MQTT. So when looking globally, the quality of service level number 2 requires the most resources for it to be implemented. So if you are using quality of service level 2, it is consuming a lot of resources for the communication to happen, because it needs to send multiple acknowledgement messages and receive some acknowledgements back from the transmitter for the entire communication to happen and complete successfully. So because of that, quality of service level number 2 requires the highest amount of resources when compared to the other two protocols, other two quality of service levels. So the quality of service levels, those are the quality of service levels that are basically defined. So like we will actually discuss, we need to discuss about these quality of service levels further. And also, you can obtain more information about the MQTT protocol using mqtt.org website. So if you are able to go to this website, you will be able to see that it contains different information such as MQTT and its implementation. So you will be able to obtain data regarding the protocol using that website. The website will allow you to find information regarding the importance of MQTT protocol and the different applications where the MQTT protocol is used. Right. So if you have any doubts or any information regarding the protocols, you can find most of them with this MQTT website. And also there are other resources that explain about the MQTT protocol. So MQTT protocol is a popular protocol, and it is used in smart homes, smart office environments, and it has been proved to have lesser latency than other protocols that consume a lot of complex messaging between the transmitting device and the receiving device. So MQTT protocol has a lightweight feature when compared with protocols that consumes a lot of resources to do the communication. Those sometimes those protocols have many functions to work with, but MQTT protocol does not have much functions, and it will only store the data in the broker, and then it will transmit the data to the necessary parties. So a lot of computational computational work has been removed, and it has been made as simple as possible. The MQTT has been made as simple as possible, so it can be used for IoT scenarios where the energy is limited at the devices and the other resources are limited in the network. So regarding the MQTT website, that's all. So I mentioned to you about the MQTT quality of service levels. So those quality of service levels must be taken into consideration when you are implementing the MQTT protocol. right? Another thing that you need to know is that MQTT protocol can be, implemented through the port 1883. So that is something that we looked about. 1883 is the default port for the MQTT communication, right? So out of the three QoS levels that we discussed about, basically QoS level number 2 is the maximum QoS level defined for the MQTT protocol, right? So do you have any questions related to the QoS levels? Right. So I believe I will explain more about these QoS levels in the upcoming classes, right? So I believe you need to have a fresher, like a start to discuss about that. So there are some, some like data related to each of the quality of service level, and we need to know how the protocols work. And I think it would be better if we learn about that at the beginning of the lesson rather than at the end. So I think I will discuss more about the quality of service in the upcoming classes, right? So if you don't have any questions, I think I will give a small quiz now. So I will share the quiz with you as I did last time. You can join the link that I have given in the chat, or you can use the game pin as well. Okay, so I will start. So the correct answer is 1883. I think only one got the correct answer. So the correct answer is QoS level number 2 is the maximum QoS level defined for MQTT. So the correct answer is not selected. So 0, 1, and 2, it's the correct, I mean, those are the levels, but maximum QoS level is the number 2. I hope it's clear. Okay, so this is about ESP32 microcontroller. So it is regarding the company. So the correct company is the Espressive Systems. Espressive Systems, and it is a company based in China. So Arduino is a wrong answer. ESP32 microcontroller has been developed by another separate company. So the correct answer is supporting multitasking. So I think you got the correct answer. So you can do multiple multitasks using the dual core processing ability. So parallel tasking can be done. Which of the following is not a feature of ESP32? Yeah, so single core processor is the correct answer. So there are two cores in the ESP32 for processing. So all of the rest is the correct answer. So it has analog to digital converter pins. So once you give analog input, it can be converted to digital output using that pin. Then touch pins, ground pins, those are also available in the embedded system. So touch pins is some unique pin type that is available in ESP32. So it is therefore a special function that is enabled with the ESP32, that is found with the ESP32 touch pins. So it is used for different touch interface based applications. So once you give some kind of a touch interface connection to the pin, then the pin will take the output as output voltage as 1 if there's some kind of touch detected. So ultrasonic sensor. So ultrasonic sensor is used for distance measurement using ultrasonic sound waves. So yes, so the purpose is to initiate measurements and receive the distance data. So which application is used with ultrasonic sensors? Object detection and avoidance. Yeah, the first one is the correct one. So device-device communication directly between two devices can be done using ESP now protocol. So that is the correct answer. So with that, I think we will end the quiz. And I think only two are there in here in the quiz. So therefore, I think the marks are like this. So so have you mentioned your ID numbers correctly in the as the names? Because once I give the marks, I need the ID number as your name in this quiz. So next time, if possible, mention your ID number directly, and then also you can put your name as well in order to make the marking easier for me. I will add the quiz marks as a bonus mark, which would actually the maximum mark that I will add from all the quizzes will be maximum about 3 marks, but that will be added as a bonus mark to your mark. So regarding the quiz, do you have any questions regarding the quiz or any clarification that you want to make?
No, miss.
Okay, so I think like for the moment I have to